today's lesson, section 6.5, we'll be talking about the law of sines. Now, I have stated what the law of sines is. Law of sines is sine of your angle over a side opposite of it, so A, which equals the sine of B over B, which equals the sine of C over C. Okay, so this is basically just a proportion that we can use given whatever information we law of sines is used when we have triangles that give us the following information, where there's an angle and then a side and then an angle, so a side in between two angles. You have a side and then two angles in consecutive order, or two sides in consecutive order and then an angle. Okay? Now, two of these, so the SA and the SS or SAA, only give you one solution, so you don't have to worry about anything other than using the proportion. The one that's tricky is the SSA, which is an ambiguous case. So, for this particular one, there are three possibilities for solutions. You could have no solution. That means that your angle is too great and the side opposite of it is too small to connect to whatever side C would be to create an angle for B. So therefore there's no triangle that's possible. There is a one solution, just like ASA and SAA triangles. You have one solution that only works for this, or you could have two solutions where your angle is just the right size and your side opposite of it is just the right side, where we can make one side and then swing it around and make another triangle with a different angle. Now, the reason you were able to do that is because you don't know what C is yet, because you haven't found it, nor have they given it to you. So the possibility for angle C and side C is numerous, because you don't know what it is until you actually sit down and find them. Okay? So the first example is a triangle where you have no or one solution. Okay? So if I have an angle A of 45, my side opposite of it is 7 squared of 2, and then the side next to it is 7. I want to know if it connects, so I need to use the law of sines. So sine of 45 over 7 squared of 2 equals sine of B over 7. Here, since it's a proportion, I will cross multiply, and then I will try to solve for angle B. So in this case, I'll need to divide both sides by 7 squared root of 2. Okay. So that leaves me with sine of B on one side. 7's crossed out on the left, so I'm left with sine of 45 over square root of 2. Remember that sine of 45 is the square root of 2 over 2. So this is the same thing as saying square root of 2 over 2, comma, square root of 2, or over square root of 2, which is the same thing as over 1. So I could multiply by the reciprocal here. My square roots cancel each other out, so I actually have sine of B equals 1/2. So using your inverse values that we just learned last section, we want to know what the inverse sine of 1/2 is for beta. Well, in the first quadrant, that would give me an angle of 30 degrees. So B is 30. Okay? Now, for each law of sines, we need to actually check to see if there's another angle. So how to do that is we take our angle that we just found, and we say that that's 1. Okay? Angle 2 for B should be 180 minus the 30 degrees. Okay? So that gives me 150. Now, I need to check with the angle that I was given to see if I have a possibility for an angle C that could fit in there to make 180 degrees. If it's greater than 180 degrees, then there's no possible way that that's a solution for angle B. So then we're left with 1. So here, if I add 45, which is angle A, I get 195. So therefore, this is way greater than 180. So this is not a solution. So B of 30, or angle B of 30 degrees is the only possible solution. So then from here, now you can go on and try to solve for the rest of the triangle. So I need to find angle C. So 180 minus 45 minus 30, so the two angles that I'm given, gives me 75, so it gives me 105 degrees. Okay, so there's the third angle. So now using that and law of sines, I can do sine of 45 again over 7 squared root of 2, and then times sine of 105 over c. So now I can cross multiply again. So c sine of 45 equals 7 squared root of 2 sine of 105, okay, divided by sine of 45 to get c by itself. So then here, remember that that's now, because 105 is not on the unit circle, so I might as well just plug this one in to figure out the angle measurement, even though I know sine of 45 is square root of 2 over 2. I only like to use those if it's going to come out nicely, like the 30-degree angle did. So here, punching it in, so 7 square root of 2 sine of 105, make sure your calculator is in degrees, divided by sine of 45. That gives me a value of 13.52. So then that would be the three missing pieces that I needed to find. Example 2 is similar to example 1, so I first need to find the angle 1, or sorry, the first angle for B. So sine of 43.1 over 186.2 equals sine of B over 248.6. So I cross multiply. And then I divide. Here I have all decimals, so I'm just going to divide it in the calculator already. That gives me a value of 0.912. Then I do my inverse to find the angle measurement, and that gives me the angle measurement of 65.78. Okay? So here, remember to check. So let's say that's 1. So let's say B2 is 180 minus 65.78. That gives me 114.22 degrees. So let's check. Add that to your previous angle of 43.1. That gives me 157.32. So that means that I can fit another angle in there for C. So I have two solutions for this problem. So here, since I have two solutions, now I need to find C for each. So angle C will be 180 minus 43.1 minus 65.78. That gives me an angle of 71.12. Over here, if I do the same thing to find angle C for 2, so 180 minus this 157.32, because that's the addition of both. So then that gives me gives me 22.68. So then those are the two angles for C. Now I need to do law of sines again for both. So let me quick set that up. So now I set up both of my law of sines for each individual side. So I cross multiply for both. Now the reason I use the original values is to get the most accurate answer possible, since I'm dealing with all decimals. So here I will have to divide by sine of 43 for each. And then that'll get me a side of 257.85 and a side of 105.08. Now the last example, we need to solve the following triangles. So here, first I'll set up my law of sines. So sine of 42 over 70 equals sine of b over 122. So here I'll need to cross multiply and then divide. So that'll give me a value of 1.166. Then I need to take the inverse sine of that value. And that gives me a value of something that my calculator says that there's an error. Now the reason for this is if I look at this value and think about the range for sine, or the domain for sine, remember that we said that it was from between -1 and 1. So since this is greater than 1, therefore I can't find the inverse of sine because it's not actually on the unit circle. So in this case, that would be a no solution. So that means that there are no values for angle B that make this triangle work, because the opposite angle and side do not connect to the side C that should be there. Okay? And that's how we use law of sines. The other triangles that I didn't really show, I just mainly showed triangles that had SSA, work the same way. You just don't have to check. But it's just a good thing to check every time you use law of sines, because you never know, or you're not truly ever thinking about what kind of triangle you're given. You're just able to say, oh, I can use law of sines. So just make it a habit to kind of check for an extra angle in law of sines, and if it works, then you have two triangles. If it doesn't, you have one. If it doesn't even give you an angle for B, then there's no solution. Okay? Have fun.